So next up we have Georgy as Sambarov, and they're going to be talking about analysis of the dynamical evolution of the Quadrantid meteor stream.
Hello. We know the Quadrantid is one of the strongest meteor shower. The present body of Quadrantid is asteroid 2003 H1, while the part of stream is connected with comet 96 PM Meteoroids. The asteroid 2003 H1 is expected as a domain or recently extinct comet in many walks. The asteroid and Quadrantids locate in a resonance zone. In this walk, we try answer the following question: are the orbit of meteoroid stream stable? How is the period in which the orbit can be regarded as stable long? What is the case of charts of in motion of meteoroid stream? What resonances are manifested in the Quadrantid meteoroid stream? We model in ejection particles from the parent body. A method of stream modeling due to chemistry velocities sublimation is widely well understood and was reported many times by many authors. The main idea of method is the generated ejection of some amount of the test particles at some point on the orbit of a parent body, and following the evolution of each of them approach of our choice. We simulated ejection of 100 model meteoroids at perigee passage of parent body approximately 1764, 1769, and that's all. At summary, we have 500 particles. In this experiment, we confined ourselves to the following points. The first observation show around 35 years. The asteroid is the core of the stream. Asteroid orbit stable on the time interval 70-60 or nowadays 2-parameter magna. In figure, we present a short time variable of orbital parameters of model of Quadrantid meteoroid stream. We investigate the orbital evolution at each ejected particles from moment of ejection until now today. For example, this is first part 100 particles, the second part the hard ejected particles. The semi-major axis remain at very close 3.1. The behavior of model particles are not characterized by larger various inclination and eccentricity on this period, but parameter magna divided the two sides. This is meteor stream for half simulated particles. This is parameter present the chaotic motion, for example. We back to basic articles who created this parameter magna and see how, for example, this is a picture by Cincotta present how on this period 0 to 1000 years this parameter magna increase, how we see on this picture or this picture. But if you see the next moment after the 200,000 years and 10,000 years, this is parameter stabilization this is present or about the quasi-periodic orbit. We think about it and we suggested that the same may happen in simulation when the numerical integration is performed for a long period of time. Which is present one of testing particles for one injection. Figures show how vibration argument perhaps is on this period of time and this period of time. Also, eccentricity and inclination have not vary, exchanging energy each over for some particles. For all particles, this interaction is not preserved, and the orbital element have unstable change with time. For example, this is as very and if you see of some particles have very changes semi-major axis is very big changes. We will demonstrate this moment on various specific particles. For example, we present chaotic motion for one particle and present regular motion for one particle. If you see on the regular simulated particle, this simulated particle does not have many frequent cross with Jupiter. The gray horizontal line is sphere, radial sphere here. This particle not have many frequent cross encounters with Jupiter, but transfiction the argument perhaps is from vibration and small moment circulation and another vibration. The parameter beginning grow near the 5,000 years. After this moment, the orbit maybe have a small chaotics. If you see a chaotic orbit from the moment ejection, the parameter magna linearly grow, and you see how is don't save combination, inclination and eccentricity, and how changes various argument perhaps is. We see, for example, on this maybe have describe how resonance read of quasi, but on this picture this is resonance not saved, and you see semi-major have various changes at near 4,050 years. This stable acceleration similar to those associated with radio quasi, where we see integral energy, what have safe over all time period, and we see this is particle not have close apertures with Jupiter. But if you see on the this picture for chaotic motion, we see how particles have more frequent close apertures with Jupiter, and with this integral have more changes. and our analysis of dynamic meteoroid particles assumed to be released from the asteroid 2003 H1 released the complicated dynamic structure on its meteoroid stream, which approaches Jupiter. The increased parameter magna has been observed in moment of changes, semi-major axis caused by multiple approaches with Jupiter near Hill sphere that can be a source chaoticity. Gravitational perturbation from the Jupiter at frequent close encounters with this planet brings up interesting drastic changes on orbital evolution, some simulated particles. They exist from exit from resonance with of quasi contributes of manifesting of chaotic motion at certain particles. Simulated meteoroids inherit the dynamic properties of asteroid, but not all these properties. Thank you.
Thank you very much. Any questions? Got some time for some questions.
Okay.
No? Oh, yeah.
Do you see any particle of the continuously located in the causality of mechanism, resonance?
When continues?
Continuously for your 1,000 years or something like that. So.
I see on this long period for 750 years old, but I present some particles, how describe what is manifesting in this quadrantid meteoroids. But I studied for some ejection particles and study for all this is moment.
Okay, so you cannot see any particle. Any particle within the causality of resonance.
I see four wall, but I present, for example, how describe how is moment with parameter magna increase, how is moment parameter magna changes. Because if you see on this illustration, we maybe understand how is particles chaotic, how particles regular, because this is if you took on this picture some different particles from some different ejection, we see spread the only red point.
Okay, I will talk to you later.
Right, let's thank Georgy again. And our final talk before coffee is Enchanté.